Okay, so welcome to this short little lesson on ionic bonding. Now, to be really clear, we are only going to focus here on ionic bonding diagrams. We're not going to look at the properties of ionic compounds. We are just looking at how to draw bonding diagrams. There'll be a different video on the properties. Now, if you watched our last video, you will know that ionic bonding is always between metals and non-metals. Okay? Metals being on the left of the periodic table, non-metals being on the right of the periodic table. So as soon as you identify this, you should know that you have ionic bonding. Now again, the key is in the name. It is ionic bonding, which means again it must involve ions. As a little refresher, if you watch the video, you'll already know what an ion is. But an ion is an atom that has lost or gained electrons. And it will be either positive or negatively charged. Could be 2 minus, could be 2 plus, could be 3 plus, could be 3 minus. Okay? The charge can vary depending on the loss or gain of electrons. Now, really importantly, when we're looking at this, we need to be able to describe what an ionic bond is. Now, an ionic bond, as we mentioned last time, is the electrostatic attraction between the oppositely charged ions. Okay, so if you're asked for the definition of an ionic bond, that is it. Okay, it's the electrostatic attraction between the oppositely charged ions. Now you could say between positive and negative ions, that would be okay, but I would advise you not to. Okay, my advice would be stick with oppositely charged ions. It is much, much easier. Now, let's start to look at how we can put together an ionic bonding diagram. Now before we do that, we need to make sure we are comfortable drawing atoms. So the first one we are going to look at is we are going to look at sodium. Now sodium symbol is Na, if you find it on the periodic table, and we have a 23 at the top and an 11 at the bottom. Now the number that we are interested in is this bottom number here. Okay, what do we refer to this number as? What's it called? Have a think. Good, yeah. Okay, so this number here, this is going to be the atomic number. What about this one? What about the top one? What's that one going to be? Yep, that one's going to be the atomic mass. Now the reason these are so important is these are going to tell us about the subatomic particles in our atom, and we need this to be able to work out the ions. Now, if you think back to the atomic structure unit, and this is where we need to start to link units together, the atomic mass is going to be the number of protons and neutrons, and the atomic number is going to be the number of protons. Now, you might be thinking, well, we've not mentioned the electrons anyway yet, but atoms are overall neutrally charged. Now if I've got, in this case, 11 positive protons, that means I must also have the same number of electrons. So I have 11 protons and 11 electrons in this case. So if I were to do P, N, E, I would have 11 protons, and protons are positive. I would have 23 minus 11 neutrons, so I would have 12 neutrons. Neutrons are neutral, and I would have 11 electrons. Now, obviously my electrons will be negative. Okay, so I've got 11 minus, 11 plus, overall neutral. Atoms are always overall neutrally charged. Now, we said that an ion was one that had lost or gained electrons, so that's what we're going to need to do in a minute. But first, let's just check we can draw an atom. So sticking with sodium for a minute, we said we had 11 electrons. Okay? Now, in order to draw the atom, or the electronic configuration of the atom, we need to follow the 2-8-8 rule. And this tells us that in that inner shell, we can only put 2 electrons. So 1, 2, like that. In my next one, I can put up to 8, like that. And in the next one, I can put up to 8 as well. Now, I don't have 8 to put in, I only have 1. So I'm going to put 1 electron in that outer shell, like that. Okay? Now, if you notice, there's something else here that's a really, really nice tip. Sodium has 1 electron in its outer shell. Now, it's also in group 1. And all of the group 1 elements will have 1 electron in their outer shell. The same for group 2, the same for group 3, the same for group 4, the same for group 5, 6, 7. Okay? Really, really important. The only one that doesn't really obey that is group 0. Okay? Group 0 have a full outer shell. So, when these things react, they react to get, and they all want to achieve a full outer shell. That is the aim. When these things react, they want a full outer shell. So, if my sodium reacts, it essentially has 2 options. It can lose this 1 electron here, which would give it a full outer shell here, or it could gain 7 electrons to have a full outer shell on the outside, remembering that 8 electrons is the magic number for the full outer shell. Okay? Now, chemists are lazy, atoms are lazy. They will always do the easiest thing. So, is it going to be easier for them to lose 1 electron or for them to gain 7? Perfect, yeah, hopefully you got that right, and you said that it would be easier for it to lose 1 electron, like that. Okay, so if it loses 1 electron, I've now got, my protons are still 11, so I've still got 11 plus, okay? But now, although my neutrons are still the same, they're 12, my negatively charged electrons have gone down by 1. So overall, my atom, or my now ion, becomes positive, and I draw my ion like that. So that would be an Na plus ion. Now, importantly, when you are drawing these in the exam, you only need to show the outer shell when you're drawing ionic bonding diagrams. So, in the case of sodium, it has no electrons left in its outer shell. So actually, we can get rid of all of that, and our sodium ion can just look like that. Okay, Na plus. Lovely. Right. Let's see then if you can have a go at doing the same for magnesium. What should a magnesium, we'll draw a magnesium atom, and we'll draw a magnesium ion. What should they look like? Okay, so hopefully you managed to draw the magnesium atom. Magnesium will have 1, 2 in the inner shell, because it's the 2-8-8 rule, remember. Then we've got 1, 2, 3, 4, 5, 6, 7, 8 in the next one. And then in the one after that, we are going to have 1, 2 electrons. Okay? Again, what group would this be in if it's got 2 electrons in its outer shell? It would be in group 2. Okay? A nice little giveaway there. Now, simple question, is it easier for it to gain 6 electrons or to lose 2 electrons? Very easily, it's easier for it to lose 2. If it loses 2 electrons, the charge on the ion will always be 2 plus. Okay? Always be 2 plus. Now, one other nice little tip here when you are trying to figure out the charges is this. Metals will always form positive ions. Okay? For the purposes of GCSE, metals will always form positive ions. So, we've looked at the positive ions. Let's now move on and have a little look at perhaps some of our negative ones. So, to do this, we are going to draw chlorine. So, if we were to draw chlorine, again, 2-8-8 rule, 2 there, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. There's an atom of chlorine. Okay, it's got 17 total electrons. At the moment, it's stable, it's neutrally charged, but it wants a full outer shell. So, is it going to be easier for chlorine to lose its 7 outer electrons, or for it to gain 1? yeah, it's going to be easy for it to gain 1. Now, it's really important here that you show this as dot and cross. I need to show this as a gained electron. Okay, I need to show that as a gained electron when I'm drawing it. Now, if we've gained a negatively charged electron, chlorine's got 17 protons, but it's now got, if it gains that, 18 electrons, which is going to make it overall negatively charged, like that. Okay, now again, we only need to draw the outer shell, so we can get rid of this one, and we can get rid of that one, like that. And there is my chlorine ion, my negative chlorine ion. Okay. Okay, right, let's have a go at one more. Let's have a go this time at an oxygen one.